So now we're going to get to graph functions, and this is where it's even more fun. And what we need to keep in mind is we can graph functions to get a visual. Also, graphs. You got to know about graphs because they're going to be with you the rest. And if you can start, you'll get to the point where you can start to see the graphs in your head, what they might look like or the general idea of it. It's really helpful if you do. And we're going to get a visual representation of the relationship between two quantities. We graph these on a coordinate plane, so a grid down here. That's a coordinate plane. It's called the Cartesian plane is what it's actually called. So named after Descartes. Cartesian plane is what it's named. But it's also called a coordinate plane. But we may not always use the variables x and y. It's named after Descartes. So if any of you read about Descartes, he's the one who came up with the coordinate plane, or he's credited with it. To graph a function, we first need an input-output chart or table. For now, we're going to get to the point where we graph them other ways, but for now we're just going to use a chart or a table to give us the points. So we're going to look at this function right here, c of t is equal to 2t minus 3, and create an input-output table. Since we're not using x and y, think about which variable is the input and which is the output. And we're going to plug this into our table. So look at this. What's our input? Our input is right here. That's what can go in. That's t. What's our output is the function. Okay? So we're going to pick values. We can pick any values we want to for x. Let me give you a suggestion. Okay? My suggestion, not required, but because I know sometimes graphs do funky things. You always want to check for a negative. Always plug in at least one negative, 0, and a positive. At least that many. Okay? You always want to have at least 3 points. It only takes 2 to determine a line. You'll learn about that in geometry. But if we have 3, it's more accurate. 5 is even more accurate. So we're going to go with 5. So let's go from lowest to highest. It just kind of makes it convenient. I'm going to plug in 2 negatives and 2 positives. So I'm going to plug in a 0. Let's just pick 2 negatives. If you were in class right now, I'd let you choose the numbers. But you're not. So I'm going to pick -2, -1, 1, and 2. And this is kind of always my fallback. Those are the ones. If I'm picking 5, I kind of use that. Now we're going to plug those into the function. We're going to find out the output. Okay, so we're going to find c of -2. And I'm going to find c of -1. And I'm going to find c of 0. Pause yours right now. Let's everybody find those 5 values, and then we'll compare. After plugging all the values in, we found out that c of -2 was -1, c of -1 was 1, c of 0 was 3, c of 1 was 5, and c of 2 is 7. And if you ever get to a point you're going, wait, that was too fast, just pause your screen. Go through and look at the work. Not a problem. You're always welcome to pause it. You're the one doing it. You get to control it. You're kind of like the input. You get to control it. Okay, we weren't given values for input. We might need to make up our own. Consider 5 points. The more points we have, the better. Oh, I already said that. Okay, now we're going to plot those points. We're just going to plot them. So each line is worth 1. So I'm going to go -2 on the x-axis, because this is your x, this is your y. So we're going to plot those points. We go -2 on the x-axis, because our input, that's going to be like our x and our y. I'm going to go -2, -1. I'm going to go -1 and 1. 0 and 1, 2, 3. 1 and 1, 2, 3, 4, 5. And 2 and 7. 1, 2, 3, 4, 5, 6, 7. Now, I plotted the points. Is this going to be continuous or discrete? Right now, it looks like it's discrete. Could I have plugged in a fraction here? Yes, I could have plugged in a fraction. I could have plugged in a decimal. But it's way easier to use integers when we're going to graph. We can use fractions. That's not a problem, but it's going to be way easier. So this is continuous. What that means to us, why we care about that, is we're going to connect the points. If it was discrete, we would not connect the points. Okay? But this is continuous because we can plug in fraction. It's continuous because the line continues. So it's continuous. Here's 2 ways to think of it. One, the very basic, is you can plug in, or your domain can be, I should say that, domain can be you can plug in fractions, decimals, whatever. The other reason is because a line is continuous. It goes forever and ever in two directions. Continuous. Okay? So, let's go to the back. Since we're graphing by hand, it is easiest if we work with integers. And I was kind of referring to that already. You could choose fractions and decimals, but man, it's easier to graph integers. I'll show you if we have to graph fractions what we're going to do. So, some functions have fractions and decimals or even square roots that makes our choice of inputs critical. Or just easier. It's not critical. Nobody's going to get hurt by it. But it sure does make it easier. I would actually say easier. That's my opinion. Okay? Consider this function right here. And that function, I'm going to rewrite it because I don't like when things are slanted for fractions. 1/4 b. Okay? If we choose b is equal to 1 and we plug that in, we're going to get 1 1/4, which is a fine answer. We can use that, but it's a pain to graph. Okay, it's not really that big of a pain, but you have to go 1, and then you have to go 1/4 up and approximate where that is. It's just probably a little more accurate if we use integers, okay? So therefore, we're going to choose things that are going to make it easier. If I ever have oh wait, let me finish the sentence. Therefore, you should choose values for b that can multiply by 1/4. Okay, for this problem, that's the truth. But what you want to keep in mind is if you ever have a fraction, here's what I would do. Multiply by a number that's divisible by the denominator. Multiply by a number that is divisible by denominator. Okay, so here is 1 divisible by 4? No. But is 4? Yeah. And here's the other big hint. Use the denominator for sure. Okay, so here we're finding b, and we're finding a of b. This is going to be our x value. This is going to be our y value. This is our input. This is our output. Those all mean the same thing. This is our domain. This is our range. Okay, they all are talking about the same things. So we're going to plug in values. I'm going to definitely use 4. I'm going to use 0. I'm going to use 4. I'm going to use -4. Well, what is something else that's divisible by 4 that's pretty little? -8. Awesome choices. So now we're going to plug that in. So we're going to find a of -8. And we're going to find a of -4. And we're going to find a of 0. We're going to find a of 4. A of 8. Okay, I'll do the first one with you, then you're on your own. Okay, so now we're going to plug in -8. So I have 1/4 times -8. You can cross cancel here if you want to, or just multiply across. 1 times -8 is -8 over 4, which is -2. Okay, so you're just going to multiply. You're going to do that. Try it on your own. We'll compare in just a bit. So far I'm almost done, but I wanted to show you what I was talking about by cross-canceling here. Remember, I can divide this by 4, divide this by 4, and I get 2. Okay, so my answers are -2, -1, 0, 1, and 2. Again, if you didn't get those answers, pause your screen, look over my work, and ask questions. Now we're going to plot those points. So we're going to go -8, -8, 1, 2, 3, 4, 5, 6, 7, 8, and -2. Then we're going to go -4. Hey, you know what? Try plotting it on your own too. That'd be good practice. Okay, so if you plotted all the points, it would look like this. Now you want to take a straight edge. And the reason I said straight edge is you might not have a ruler hanging around, but you might have an index card. Your student ID is an awesome straight edge. So if you're ever carrying that, use that as your straight edge. Okay, then you just connect them because this is continuous. So I'm going to connect the points because it is continuous. Why? Because a line, because you can plug in fractions and decimals. I'm going to show you how you would graph it if we would have plugged in 1. So if we would have chosen 1 here, we would have gotten 1/4. Let me show you how you'd graph that just for future knowledge. Here is 1, and see how 1/4 is going to be about right there. That's as exact as you have to be. So if I'm going to ever graph a fraction, I just have to get it someplace in between. Now it's easy to graph here because I already have the line drawn. But again, the reason it's continuous is because you can plug in, can use fractions and decimals in the domain, in the input, whatever you want to say. Okay? So, just to let you know, that's what it's talking about. Okay, now let's look at a different kind of function. Let's look at the square root function. F of x is equal to the square root of x. Okay, when these things get typed up, unfortunately, it doesn't cover it, but it's all underneath that radical. Remember that we cannot take the square root of a negative right now. Okay, that's future. And even when we can take it, if we're actually graphing it, you're not going to graph it. But for now, we cannot take the square root of a negative. So keep that in mind. It's going to be very important when we determine our domain and range and what we can plug in. Next, we should consider inputs that have integer square roots. Okay, what the heck does that mean? Integer square roots, that means perfect squares. So we want to get outputs that are perfect squares. So when we plug in, we might want to be very careful on how we plug in. Okay, so we're going to take the square root. So we're going to look at our perfect squares. And we want to be able to take the square. We're going to look at what our perfect squares are. So here our function is f of x is equal to the square root of x. So this is x. This is f of x. Okay, so if we look at our perfect squares, oh, can I put in, and remember what I recommended, a negative, 0, and a positive. I can't plug in a negative. Won't work because I can't take the square root of it and graph it. So ever can I graph it. Now, if I plug in 0, that's a perfect square. I get 0, square root. If I plug in 1, is 1 a perfect square? Yes, it is. I can take the square root of 1 and I get 1. What's my next perfect square? Well, just think 1 squared, 2 squared. Okay, that would be 4. So what I'm doing is I'm finding f of 1 is equal to the square root of 1, which is 1. F of 4, but I'm picking my x values very carefully. I'm picking perfect squares, so then I can take the square root of them. I don't have to worry about decimals. Okay, 2 squared, 3 squared, 4 squared, right? So f of 9 is equal to the square root of 9, which is 3. F of 16, square root 16, which is 4. So you might be thinking, didn't you kind of manipulate the data? No, we're just using it. If we're going to graph it, we want to make something that's going to work for us. So I go 0, 0. I go 1 and 1. 4, 1, 2, 3, 4, and 2. 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 3, 1, 2, 3. Now, 16 and 4 is off over here somewhere. This is enough points for us to get our graph. And this graph is a curve that goes out that direction. Yes, it's continuous. Because we know we could have plugged in lots of other things, but we didn't want to. We don't want to have to graph it. But we can plug in fractions and decimals. Okay, let's look at your homework. Now on this page, we're very kind to you. We pick the x values that you're plugging in. We pick them for you. You're just going to plug them in, find the y values, and plot the points. You got that. Now on the back side, we're going to ask you to pick the x values. What would be good x values? Most of the time it is fine. Okay, I would recommend negative, 0, and positive if you ever can. So I would recommend a 0. If I were doing this, I would pick a 0. I would pick a negative. I would pick a positive. And for the most part, that's kind of what I'd use, a negative 2 and a positive 2. I have a fraction. So think about what would I want my x values to be. Okay, what would I want my x values to be? So obvious ones, 3 and 3, negative 3 and 3. Pick some other obvious ones. What's divisible by 3? Okay, same thing there. Here, we have a square root. We know our x values cannot. We can't get a negative underneath. So what would make that a negative underneath? Actually, what you want to do with these is, how can I get that to be a 0? What could I plug in for x to get a 0 to be my first one? So keep that in mind. I'll let you play with that. Same thing here. Now this is a negative on the outside. I said you can't take the square root of a negative, but you can have a negative square root. That's totally legit. So you can have a negative square root. Here, pick anything. You're going to be fine. That's not a difficult one to do. Okay, so make sure that you do this, plot the points, be familiar with it. If you have questions, you know where to find us. Thank you.